Hello everyone, let's try a geometry problem today. It's quite beautiful actually. It's from AMC 12, the American mathematics competition. But it uses a principle from geometry which has been used over and over again over the years. So we start with a square ABCD and we take a point P inside the square. The position of the point P is not completely random though. It's given that PA is 12 and PB is 26. And also the side of the square is given to be 30. So all of this is given data. What we do next is we join the point P with the vertices of the square. We mark the centroids of each of these triangles. So there are 4 triangles, so there will be 4 centroids. What is a centroid? Centroid is the point of intersection of the medians of a triangle. So if you join the vertices of the triangle to the opposite midpoint of the opposite sides, that line is a median. And if you join the 3 medians, it's a theorem in geometry that all of those 3 medians will pass through a single point. That point is known as the centroid. Maybe most of you know this, but if you don't know, I just gave you a brief recap. Okay. Now let's call these points R, S, T, U and join R, S, T, U. So let's join these. At the end of the day, we want to find the area of RSTU. Area of RSTU. This quadrilateral. So that is our goal. That's the goal. Now to do that, we will start with a very simple but very useful idea. And that is that RT and US, the diagonals of this quadrilateral, they are parallel to the sides of the square. So what I'm trying to say here is, step 1, show that RT is parallel to AB. Okay, RT is parallel to AB. And similarly show that US is parallel to BC. US is parallel to BC. Now you can pause the video here and give it a try. I will give you 2 ways of showing this. One, using the notion of vectors or complex numbers or complex coordinates. And the second one is using pure geometry. That's what makes it exciting. I mean, you can do this using 2 different but beautiful methods. And then I can use this information to find out the area of the quadrilateral. That part is actually very easy. You can use the length of RT and US. You can figure that out. You can figure out the length of RT and US and you can use that information to find out the area of the quadrilateral. Okay, so how do we show, so let's start with this one. How do we show RT is parallel to AB? Now, it's very simple actually, but we will start with the method 1. So this is method 1, which is geometry. So I'll be using pure geometry to show that RT is parallel to AB. So how do you do that? Okay, so let's connect P with U, use the centroid and produce it to hit AB. Let's call this point X. Now since this is a median, remember centroid is the intersection points of the median. So PX is a median of this particular triangle, which means X is the midpoint. X is the midpoint of AB, right? Similarly, I can join PS and produce it to hit the midpoint of CD, which is let's call it y. Let's call that point y. Now let's join xy. Let's join xy. So x is the midpoint of AB, y is the midpoint of CD, and we join xy. So this line xy is parallel to BC. You can easily check that if you join the midpoint of opposite sides of a square, that line becomes parallel to the side of the square. So xy is parallel to BC. The good news is that there is a little bit more information that we have about the centroid. For example, we know that PU is 2/3 of PX and PS is 2/3 of PY, because the centroid divides the median in 2:1 ratio. We know this. This is also an established theorem in geometry. The centroid divides the median into 2:1 ratio. So what x and y, what u and s is doing to px and py is the following. It is dividing the sides into 2/3 and 2/3 portions. So now we can see that this is creating similar triangles. PUS is similar to PXY. So we have similar triangles here, which means US is parallel to XY. But we already knew that XY is parallel to the side, so US is parallel to the side. Not only that, we know that US is 2/3 of XY, because these two triangles are similar. So US is 2/3 of XY, but XY is equal to the side, so US is 2/3 of the side, which is 30. So 2/3 of 30, that is 20. So US, the length of this diagonal is 20, and the exact same argument will work for RT. So RT is also 20, and RT is parallel to the side AB, the other side of the square. So US is perpendicular to RT. So this is what we have learned. US is 20, RT is 20, and US is perpendicular to RT because US is parallel to one of the sides and RT is parallel to the top side. Okay. So now, using this information, can you find out the area of that quadrilateral? Can you find out the area of the quadrilateral? It's very easy now. If you are a little bit confused, you can Google the words kite and how to find the area of a kite. Okay. So this is actually a kite. Their diagonals are perpendicular to each other. Why don't you put the final value of the area in the comment in the description? So use the fact that US is perpendicular to RT and each of them is 20 to find out the area of this quadrilateral, and give me the final answer in the description, comment in the description. Also, I'll give you another way of doing this same problem. Another beautiful way using the notion of vectors, but I'll do it in the next video because it's getting too long, this particular one. Till then, give me the answer as a comment. I'll see you in the next video. Take care and keep on doing great mathematics. Bye.